When we're talking about our CPUs, there's a couple of characteristics that we need to be aware of. The first one that we probably want to talk about is going to be our CPU speeds. Now, the first speed that we want to discuss when we're referencing CPUs is going to be our clock speed. Well, what is a clock speed? Clock speed is the number of instructions that a CPU can execute at a fixed rate. Now, clock speeds are typically measured in either megahertz or gigahertz. Megahertz, which you'll see as MHz, indicate how many million cycles can be processed per second. So megahertz would be millions per second. We can also measure clock speed in gigahertz, and clock speed in gigahertz would be 1 billion cycles per second. And again, the cycles are going to be a fixed rate for the instructions that the processor can actually execute per second. Now, the clock rate actually doesn't 100% correlate with how fast the processor can run. And you would think that a computer that you would see has, say, a 1.6 gigahertz clock speed would be faster than one that has, 1.5 or 1.4. It's not quite as straightforward and straight cut as that. The gigahertz and the megahertz measure the number of cycles per second that the CPU goes through. Now, in that cycle, it may take one CPU longer to run a set of instructions than another CPU does. So on one CPU, it may take it, say, 20 cycles in order to do what another CPU takes one. One CPU may be more powerful in that a simple multiplication of two values takes it one clock cycle. It's finished. It moves that on. But another CPU may take 20 clock cycles. So even though that second CPU may have a higher clock speed than the first CPU, because the second CPU is taking more clock cycles to do calculations, the first CPU may have an advantage depending on how the speeds match up. In addition to clock speed, we actually have other measurable attributes that we can measure with the CPU. One of those is going to be the caches. A cache is essentially stored memory on the CPU. It's memory that the CPU can access a lot faster than, say, our RAM memory. Now, this is because our cache memory is locally stored memory to the CPU, rather than, say, having our CPU on the motherboard and the CPU has to send a car over all the way to our memory, retrieve the memory, and then send it back. Now, this happens to us in the blink of an eye. But for the CPU, it has to wait for that to go and then wait for it to come back. Whereas memory that we can put in our local cache is actually stored on the CPU itself. So say this is our CPU, an enhanced version that we can see into, and our sectors down here are our local cache. Now our local cache on our CPU is broken up into a couple different parts, L1, L2, and L3. Our L1 cache is going to be the first place that our CPU checks for information, but it's also relatively small, and we call this our L1 cache. So remember, our L1 is the first place we check, but it's relatively small. And by relatively small, we mean, a few kilobytes, not, maybe almost up to 100 kilobytes, but not very big, not like 1 gig or 2 gig when we think of our RAM. Now, the second place that our CPU is going to check for memory is our L2 cache. Our L2 cache may be a little bit bigger than our L1 cache, but again, it's going to be the second place that our CPU checks for memory. So little bit slower to access than the L1 cache because it's the second logical place that the CPU checks. Following the L2 cache, of course, is going to be our L3 cache. And then our L3 cache, some of our processors have L3 caches actually on the processor itself. And some of our processors will have L3 caches, or some of our motherboards rather may have L3 caches that are located on the motherboard right next to the CPU, closer than the memory is to the CPU. So we want to remember that our caches is local memory to the CPU, and it actually helps the CPU retain or get memory faster than having to go all the way to our RAM, all the way to pull that memory back. So our L1 is going to be our first check, relatively small though. L2 is going to be our second check, and then L3 is our last cache, our last check. Not all processors have L3 caches located locally, but some computers we may see that have an L3 cache that's on the motherboard rather than the actual local processor. Another measurable aspect of our CPU is going to be our bus speeds. Our bus speeds are the speed at which our CPU can essentially connect to other devices on our motherboard. Our bus speed helps us measure how fast it can get information places, get it back, and then use that information and process it. On our Intel CPUs, our CPU is actually going to connect to something called the front side bus. This is essentially a chip which acts as a memory controller. It helps to pass memory back and forth and point to those memory addresses. Now, this is with the Intel processors that we talked about, the Intel processor sockets. AMD processors actually do not have a front side bus. The AMD processors, so this would be Intel. So Intel is CPU, and then it uses this bus to go to the front side bus. And then we have a bus to our memory bank, such as our RAM. Now our bus speed, as you can see, determines how fast we can get that information back and forth. With our AMD, however, we don't have a front side bus. The memory controller is actually located on the CPU itself. The CPU acts as our memory controller rather than passing that task off to the front side bus. So the CPU acts as its own memory controller and then just uses a bus that we refer to as our hypertransport bus, and it goes over that hypertransport bus to our memory. So just remember, with our Intel CPUs or Intel chipsets, we're going to be using CPU to front side bus to memory, and then with our AMD, we're going to be CPU using its own memory controller and then transporting over our hypertransport bus all the way over to our memory. So, as we can see, it's not just one specific quality which we can say this processor is better than the other. We have clock speeds, we have caches, we have bus speeds, we have bus types, and all of these really go into play when we're talking about which processor we need for our computer. So it's always good to check out reviews, check out technical specifications, and then when it comes down to it, do our own tests to determine, if we can, set our own benchmarks for which processors we see as being better and more efficient for us than others.